Question 4. This question is about the impact of groundwater table on the calculation of the bearing capacity of a square footing. The footing looks like this. We have this groundwater table below the ground surface, about 1.5 meters for the part A. And a second groundwater level of 2.5 meters, which is already beneath the bottom of the footing. And part C, a very deep groundwater level, which is 7.5 meters below the ground surface. So let's consider all these three different groundwater tables. They are going to impact the selection of QS and a gamma in equation 10.1 to determine the ultimate bearing capacity. For part A, the groundwater table is above the bottom of the footing, so we can calculate QS using the bulk unit weight times the depth of the dry sand, which is 1.5 meters, plus effective unit weight, which is the gamma saturated minus gamma water, times the depth between the groundwater level and the bottom of the footing, which is 0.5 meters. And a gamma used in this unit weight term of equation 10.1 times N gamma and S gamma. We use this gamma as gamma prime. And part B, the groundwater table is beneath the bottom of the footing, so QS should be the bulk unit weight of the dry sand times D, which is the embankment depth of the bottom of the footing. And for the unit weight term in equation 10.1, we again use gamma prime. You may wonder, there is a 0.5 meters of gap of dry sand between the bottom footing and the groundwater table, but since it's a very thin layer of dry sand, so we just neglect it in the calculation, and since the calculation will be a sort of conservative, but it's completely okay. Then for part C, we have very deep groundwater table. So let's say the groundwater table is not going to impact the calculation of QS and gamma. So we're going to use QS as a bulk unit weight of dry sand times the embankment depth of the footing, And the gamma term in equation 10.1, we use the unit weight as the dry unit weight.